Hello students, welcome to my channel. Today's video is a very important video and it's an important chemical property of alkyl halides, where alkyl halides gives an alkyl cyanide with potassium cyanide but gives an alkyl isocyanide with AgCN. This is due to the fact that the cyanide over here is actually an ambidentate nucleophile. Now, what is an ambidentate nucleophile? Ambidentate nucleophiles are two donor site nucleophiles. Two donor site nucleophiles. That is, in a cyanide ion, both carbon and nitrogen atom are electron donors. That means those do have a pair of electron existing in the case of carbon. At the same time, it is existing in the case of nitrogen. Okay. So this is basically an ambidentate nucleophile. That means what? It can go and donate a pair of electron both from the cyanide, that is what, from the carbon of cyanide, and at the same time nitrogen of cyanide. So this is called an ambidentate nucleophile. Okay. So if an ambidentate nucleophile is acting on an alkyl halide, say for example potassium cyanide is there. So if I take potassium cyanide into consideration, that is what, if I take it C2H5Cl, okay, C2H5Cl is there, and if I treat this one with potassium cyanide KCN, potassium cyanide is predominantly a very highly ionic compound, okay, and it can be segregated into K plus and Cn minus ion. Whereas this C2H5Cl is there, so this can be written to be a Cl minus and C plus over there. So this is coming out to be what? A KCl, and this will be giving you C2H5Cn, and simultaneously you get a KCl. This is called ethyl cyanide or ethane nitrile in a UPSC name. Okay, as it is indicated with all the alkyl halide, it is coming up to be like this. There is potassium K plus and Cn minus is there, and this is going to attack in this K plus will go attack with the X minus, and that will give you Kx, and simultaneously RCN is obtained out. Okay, so the question arises that why the nitrogen does not make a bond with that of a alkyl group over there. The reason behind is that the carbon-carbon bond is much more stronger. If I take it into consideration about this one, C2H5Cn, which we have formed right now, the carbon-carbon bond is much more stronger than the carbon-nitrogen bond. This bond is stronger. Okay, so that's why it forms a ethyl cyanide. So that's why we prefer to form an ethyl cyanide rather than that of the formation of one ethyl isocyanide with the case of potassium cyanide. But this concept is not applicable with silver cyanide. It is being seen that silver cyanide is predominantly a very highly covalent compound. So if I take this one, AgCN, so AgCN cannot be segregated into the formation of Ag plus and Cn minus. It is impossible. Okay, because it is a covalent compound. So here the cyanide acts as an ambidentate nucleophile. The nitrogen will start forming a bond with that of the alkyl group over here. Just see, you have got C2H5Cl, you have got a C2H5Cl, and you treat this one with an AgCN. So what will happen? This AgCN is there, the Cl will be ousted, and this will be developing into a positive charge, and this nitrogen will act over here, okay, and will attack this particular positive charge. And this, since this is what predominantly covalent in nature. That is why Ag plus and Cn minus cannot be done, and therefore what happens, it cannot the nitrogen lone pair of electron goes and attacks with the ethyl group, and this will giving you C2H5N. okay, and this is plus, and this is what, a Cn NC, sorry, and simultaneously AgCl is out. Since it is developing a particular lone pair of electron is donated, that will form a coordinate bond. So it forms a coordinate bond over here. So this is forming an alkyl isocyanide. Okay, so this is what coming up to be an alkyl isocyanide is formed. So that's why you find it out, an alkyl halide, when it is treated with potassium cyanide, that is potassium cyanide is highly ionic in nature, and that's why it can be segregated into K plus and Cn minus ion, and it can form a alkyl cyanide easily. Okay, and since this carbon-carbon bond is much more stronger, that's why it is preferred to form an alkyl cyanide. But the reverse is not the order. That we'll find it out, silver cyanide cannot form that one because it's predominantly a covalent compound. That's why cyanide acts as an ambidentate nucleophile and forms an alkyl isocyanide. Same is the case with other examples of potassium nitrite, KNO2. So nitrite is also an ambidentate nucleophile, where you will find it out that ambidentate nucleophile, that means it has got two donor sides, that is oxygen as well as nitrogen, through which the attack can take place. So here same thing happens when you talk about ethyl chloride. So this is become plus and this is becoming minus charge, and you have got KNO2. KNO2 is predominantly ionic in nature. So that is why KNO2 can be represented in the form of what, K plus and ONO minus. Why not K plus and NO2? Because the thing is that if I take into consideration about K plus and NO2, because of potassium and nitrogen, oxygen is what, more electronegative in nature than nitrogen. Okay, that's why you can segregate into K plus and ONO, and that will be giving you C2H5 ONO. Okay, and if I take it like this one, and this is coming out to be and this is what KCl is out, and this is called alkyl nitrite. Okay, again when we talk about silver nitrate, okay, so this is what coming up to be silver nitrite. If it is there, then predominantly covalent in nature. Same procedure is being formed over here. So if it is like that, when silver nitrite is treated with that of the alkyl halide, so this is coming up to be what, a nitroalkane. Why? Because nitrogen will act as an ambidentate nucleophile, and this will go and attack towards the alkyl group, and that will form a nitroalkane. Okay, so I think I have made you understand a very important chemical property of alkyl halides today. Okay, so please, thank you for watching this video.